Have you ever seen a tennis ball hanging from the ceiling of a garage used as a parking gauge so you pull into just the right spot? There's got to be a better way than that. Here on B-Monster Laboratory, we're going to prototype an Arduino ultrasonic sensor measurement device. It's going to be powered by the Elegoo Mega 2560 microcontroller, and it'll have a 7-segment 4-digit display so you can easily see those numbers as you're approaching. Now this Arduino project build can be used for multiple applications, not just the garage example that I gave you. The HCSR04 ultrasonic sensor has a range of about 2 to 400 centimeters. That's equivalent to about 1 inch to 13 feet. And that makes it great for multiple applications. Let's get started. For this project, I'm using a 7-segment 4-digit display right here. I'm using 8 220 ohm resistors, which I connect to the display. I'm using a whole bunch of male-to-male jumper wires. I'm using the Elegoo Mega 2560 microcontroller. And here I'm using the HCSR04 ultrasonic sensor, or HCSR04, however you want to say that. And instead of using female-to-male wires, I just plugged it straight into my board here, into my breadboard, as you can see. Here is the HCSR04 module. You'll see here that it's got 4 pins. The VCC pin, it runs on 5 volt, and then it's got a ground pin as well. Here in the middle it's got the trigger and the echo pin. Now, you only need to supply a short 10 microsecond pulse to trigger the input to start the ranging, and the module will send out an 8-cycle burst of ultrasound at 40 kilohertz. And the 8 ultrasonic pulses travel through the air from the transmitter. Meanwhile, the echo pin goes high to start forming the beginning of the echo back signal. The echo is a distance object that is pulse width and the range in proportion. You can calculate the range through the time interval between sending the trigger signal and receiving the echo signal. These are very popular, very convenient. You'll see them a lot if you're not familiar with them. This is my setup that I have. I have 2 breadboards. I'm just using 2 for spacing. And on this breadboard I have my ultrasonic sensor. And I'm using these rails up here, the positive rail and the ground rail. And they are connected to the 5 volt pin and the ground pin on my Elegoo board. And so my VCC is connected to the 5 volt positive rail here on the breadboard. And my ground pin is connected to the ground rail. The white jumper here is connected to pin 14, and that is my trigger pin. The red jumper wire here is my echo pin, and it is connected to pin 15 on my Elegoo board. And if you look up here, I've got my 7-segment 4-digit display. It's got 12 pins. It's got 6 pins on the bottom and then 6 pins on the top. And these pins are directly connected to pins 2 through 13 on my Elegoo Mega board. Some of these pins have a 220 ohm resistor between the connection to the board. As you can see here, the location of the 220 ohm resistors are at pin 11 and 10 and 7 up on top. And then pins 1 through 5 all have a 220 ohm resistor between the connection of the display and the microcontroller. Here is a quick and easy schematic for you that I just did real quick on TinyCAD here. Not much to it, but it's more clear than me pointing out what the connections are over video. So I hope this helps. I'm pretty happy with the ability to see. I can see it clearly as opposed to using the LCD screen, the 16:2 LCD screen. And I think I'm just going to hold off on building the case for it because I'm actually going to put this thing in the garage. But I want to test out something else. Another way to do this, maybe not by using a 7-segment display, maybe another way. So I'll return here soon with another video with another way to determine range and distance in the garage. So I'm just looking for something simple and easy, and we'll see what we come up with. Here's the code that I used for this project, and you want to include the NuPing library. That is for the ultrasonic sensor, and you'll want to include the 7-segment display library. Now you should be able to get these two libraries up here at Sketch and include library, manage libraries. You should be able to just do a search right here and find those two. But the timed action, I had to go to GitHub to get this one. And once you install this, it didn't work for me initially. And I read deep in one of the threads that you had to type this line right here below it. So with that line, it works. So I don't know whether it's an issue of I didn't update or it hasn't been fixed yet. I don't know. But if it doesn't work for you, type in this line right here and all should be well. Here is the website where I got it. I got it at GitHub, glumgad timed action. So you just do a search for timed action. You come right down here and you'd install the timed action.h. So we come down here and all we do is we define the pins on both the 7-segment display, the 4-digit display, and the ultrasonic sensor. And then we come down here to our setup. We set up the serial monitor, and we come down here to the loop, and we just basically set up our ping timing. And down here I did it in centimeters. You can also do it in inches, I do believe. I will also include this code in the description below the video and also on the Facebook page. If you don't know where the Facebook page is, you can go here to the channel banner, and on the bottom right of the channel banner, the Bee Monster Laboratory channel banner, you can just click on that Facebook icon right there and it'll take you right to it. And I'll post that the code there as well. Well, that's all I've got for today. Hopefully this video was useful for you. As always, thank you very much for watching, and I'll see you again very soon.